All right, hello everybody. Welcome to the fourth lesson of cycle 3. Last time we went from vertex form to standard form, and this lesson we're going backwards. We're going from standard form to vertex form, and this technique is called completing the square. Some students do find this relatively challenging because there are a lot of steps and it seems to be kind of a magical kind of thing. I'm gonna try to explain it with algebra tiles to show you why it's called completing the square. Um, don't worry if you don't get this right away. This is not something you're gonna be seeing in everyday life. Just try your best and try to just follow the steps that I lay out. It takes a lot of practice to get this one. Okay, so let's get into the lesson here. Okay, so completing the square, cycle 3. Okay, so our learning goal today is to be able to convert from standard form quadratic equations to a vertex form. And here are the steps. So this is called completing the square. And I'm going to do a few examples of these step by step. And with one of them, I'm going to do it with algebra tiles so you can see that we are literally completing a square. Okay, so your first step is you're going to find the greatest common factor of the coefficients only of the first two terms, so the x squared and x term. Your second step, you're going to divide the number in front of your x term by 2 and square it. You're going to add that number and subtract it inside the brackets. Then there's going to be a last term inside the bracket. You're going to kick it out, but make sure to multiply that by the greatest common factor. Then we'll be left with a trinomial at the front and two constants at the end. So we're going to factor this trinomial. It's going to be a perfect square binomial and combine these constants. I know that seems like a lot, and it is, so I'm going to do this step by step. So let's do an example here. So let's say we have y equals x squared plus 14x plus 5. So the first step is to find the greatest common factor of the first two terms, but only of the numbers. Okay, now there's a 1 here and a 14 here, which means we don't really have a greatest common factor. So we're going to go to the next step. We're going to divide the middle term by 2 and square it. And then we're going to have, because we're doing this, we have to subtract it to keep this equation the same. Okay, so 14 divided by 2 squared minus 14 divided by 2 squared. Because if we do this, we have to subtract it so we don't change the overall equation. Then I'm going to put another bracket here and don't forget the constant at the end. So let's do these. So 14 divided by 2 is 7, squared is 49. So I'm just going to clean that up a bit in the next line. So these two become 49. And now you can't really factor this, but notice how we could have a trinomial here, x squared plus 14x plus 49. So what we're going to do is we're going to kick this guy out. If there were a number in front here, you would have to multiply this term by that number before you kick it out. And we'll do some like that. So let's kick this guy out because we can. Doesn't matter what order you write these additions in, right? So that way I've now have a nice trinomial and I have my constants at the back. Now, when you do this, at this point, you should have what's called a perfect square trinomial. You'll have something x squared, and the last number should be a perfect square number. So notice how 49 is 7 times 7, or 7 squared. Okay, so you should have a perfect square number there. And if we factor this, notice how If I have 7 times 7, 7 plus 7 gives me 14. Okay, that's good. So that means I can write this as x plus 7 times x plus 7. Then I'm going to combine these, so negative 49 plus 5 is negative 45. And because I have two of these, I can write it as x plus 7 squared. And check that out. That is in vertex form, isn't it? So that is how you change from standard form to vertex form. We can check this in Desmos. I'll leave that to you because I've done that in lots of previous lessons. But if you type in this equation and then type in this equation, the graphs will overlap. And again, that's another way to check in Desmos. Okay, I'm going to show you what this means. So we are literally completing a square here. So I'm going to do this here, and I hope it doesn't take me too long. What we do here is, remember the square tiles are the x squared tiles, and the rectangle tiles are the x's, okay? So I need 14 of these, right? So I'm going to make 14. So I've got 1, 2, oops, let me copy it. 1, 2, 3, 4, 5, 6, 7. Let me just, let's say we have 14 of these, but instead of just like putting 14 across here, I'm gonna put, oops, come on. I'm gonna start with putting, get these out of the way, and I'll make sure I have 14 at the end. I'm gonna start by putting one here, and then I'm gonna go back here and back here because we want to make this into a square, right? So that's 2. That's 4 in total. So we're going to do this until we have 14 of these suckers. Now, as you can imagine, you may have figured out, well, Ms. Gilbert, if you're trying to split it equally and there's 14 of them, I'm going to have 7 of each one. So yeah, that's true. So 1, 2, 3, 4, 5, 6, 7. And then oops, try to make this look nice. And then I'm going to have 5 more here, right? Copy. 1, 2, 3, 4, 5. Let's hope we can fit this in here. I have to move these. I need to fit them in here. Oh my goodness. Fit. Fit. Please fit. There we go. Okay. So there are my 14 tiles, right? So I have one x squared tile. I have 14 of my x tiles. And now I need 5 of my single tiles, which are these little squares. So 5. So copy. 2, 3, 4, 5. And let's just put this wherever. Doesn't matter. Okay, okay. Now, I have set up the outline of a square, but guess what? I need to fill in the square. I've got 1, 2, 3, 4, 5 tiles here, and I need, how many spaces do I have to fill in with these singles? Well, I've got 1, 2, 3, 4, 5, 6, 7 by 7, 49, right? So how many do I have to add to get to 49? 44, right? But I can't add 44 because that would change this. So you have to kind of add 44 and subtract 44. So to get up, I'm going to copy this. And then I'm going to make it blue because we could have all of this red, but then we'd have to take away 44 to get back to this, right? So I'm going to fill all this in with blue. And I'm going to do a line here, and then I'll copy and paste that line more times. So I think this is a really cool visual because it's like, why is this called completing the square? Because you are literally adding as many tiles as you need to complete this square that we started. So now I'm going to try to select. Okay, I'm going to try not to. I want to select this. I'm going to try to just select those blue ones. I realize I should have done this before, but then it would be fun for you guys, right? So if I select these guys, I go copy paste. I do a bunch more of those paste. I need, so that's 1, 2, 3, 4, 5, 6, 7. Okay. 5, 6. Oops. Oh no! Oh no! Okay, let me try that again. Oh no, okay, let me try that again. I'm gonna go back, redo, then I'm gonna copy that and paste that and put it there. And then paste and put that one there, and we need one more. Paste. There. Okay, so see how we have one red, remember red is positive and blue is negative. So we have 1x squared, we have 14x tiles, we have 5 positive tiles. Now I would have had to fill this in with red tiles, but that wouldn't mean this is the same. So then I have to also take away those tiles. So I have to take away 44 to get back to this. Pretty cool, eh? So that's one way of thinking about this, and what we're doing is literally completing this square. Okay? I know it's weird, but this is why we add 49 and then take away 49. Okay, so let's go back and do some more examples. These ones will have a number in front of the x squared. So remember, our first step is to find the greatest common factor of just the number of the first two terms. So I'm going to take out a 2, leaving me with x squared minus 6x plus 1. Our next step, you're going to divide our 6 divided by 2 and square it and subtract that again. So you're going to add that, subtract it again, right? Just like in the square, when you looked at the square, we added 49 and then subtracted 49 again. That way we don't change our equation. Okay, let's clean this up a bit. So 6 divided by 2 is 3, and 3 squared is 9. Okay, now we want this to be a trinomial, so we're going to kick out this last term. Now remember what I said, if there's a coefficient here, you have to go multiply the negative 9 by 2 before you can kick it out. So negative 9 times 2 is negative 18. And now we're set up. We now have a perfect square trinomial. So we've got our x squared, we've got a 9, but it has to add to negative 6, which means our two binomials are going to be x minus 3 times x minus 3. And then don't forget to add these together. And because we have two of these, the final step is to write it as a perfect square. Okay, so hopefully after you see a number of these, you'll kind of understand the steps so that you can do it on your own. Okay, let's do, yeah, again, so you can check with Desmos. Let's do one more, just a little more complicated. It's not really, it's just the exact same steps. So the first step is you are going to take out that greatest common factor of the numbers. So I'm going to take out a negative 4 out of both these first terms, leaving me with x squared minus 2x. Now you're going to divide this by 2 and square it. You're going to add it and subtract it. So we don't change our equation. If we add it, we have to subtract it. Okay, Now 2 divided by 2 is 1 and 1 squared is 1. So we put that like that, clean it up, and then we're going to kick out this last term so that we get a perfect square trinomial in the brackets. That's the goal. So -4 times -1 is 4. So that brings it out here. And now we can finally factor this guy. Well, two numbers that multiply to give 1 and add to give -2 are -1 and -1. And then out here we have 4 minus 3 is 1. And because we have two of these, we can write it finally in our vertex form. Woo! Okay, so again, you can check with Desmos if you need to. Okay, so that's it for the lesson. Um, I'd like you to do day number 5 of the Cycle 3 practice booklet. The solutions are included on that page. I think there's many, many questions, so don't worry about doing the whole thing. Just try to do it until you understand it. Yes, it is day 5. That is not a typo. Because we're reducing the number of lessons for the rest of the school year, we're having to skip some days in the practice booklet. So don't worry about that. Just make sure you do day 5. Okay. And once you feel somewhat comfortable with that, you can go ahead and try the 3.4 quiz on Brightspace. And that is it for this lesson. Um, just a note in this um, slideshow, I have added a couple more videos of someone else explaining it. So you may want to go ahead and look at those. Sometimes listen to someone else explain it is helpful. Okay, that's it for today, and I will talk to you next time. Bye bye.